Okay, let's talk a little bit about measuring matter, and as we do, we'll meet the first of the most important kinds of quantities that we deal with in 101 and 102, and that is intensive quantities. So first, it's important to realize that a volume is a cubic length. All volumes have units of length cubed. So a rectangular solid, for example, would have a volume equal to its length times its width times its height, and since length, width, and height would all be lengths, the product would be a cubic length. Likewise, the volume of a cylinder, which is pi r squared times h, is again a cubic unit. So let's determine the volume of this rectangular solid. The volume is going to be the length times the width times the height, and that's going to be 10.0 centimeters times 20.0 centimeters times 30.0 centimeters. And that's going to be 6,000. And notice the unit is centimeters times centimeters times centimeters, which is centimeters cubed. But the issue here is that 6,000 is actually one significant digit. If you had a decimal point here, it would be 4, but we're not allowed 1 or 4, we're only allowed 3. So the proper way to write this, since these are all 3 significant digits, is to write this as 6.00 times 10 to the third cubic centimeters. Incidentally, a cubic centimeter is about a milliliter. All right, well, with that in mind, suppose that this box had masses in it such that it weighed 16 grams. Suppose, for example, that each of these purple dots weighed a gram, and there are 16 of them. We know that the larger the box, the larger its mass, and we also know that the larger the box, the larger its volume. But it turns out that if you take the ratio of the mass to volume, you get what's called the density. The density is the mass divided by the volume. And even though mass and volume are themselves extensive, meaning that you get more when the size of your system increases, the ratio for a pure system or a homogeneous mixture always stays the same, even if you take a smaller or larger sample. So density then becomes a property of the substance. So our density is going to be 16.00 grams divided by 6.00 times 10 to the third cubic centimeters. And that turns out to be 2.67 times 10 to the minus 3 grams per cubic centimeter. So that now I have a way of converting between the mass of something and its volume. Okay, well, if that's the case, suppose we take this box and we divide it into quarters. And we take a quarter of the original box and determine its density. In this case, the density is going to be not 16 grams. There's only 4 of these gram size particles here. So it's going to be 4.00 grams. Now your volume is 20 by 15 by 5, and that's 1.50 times 10 to the third, and that still turns out to be 2.7 times 10 to the minus 3 grams per cubic centimeter. Okay, so the density for each of them is the same. There's less mass in this sample, but there's also less volume, and the ratio turns out to be the same. So density is a property of that substance, and the amount of the substance doesn't change its density. Density is then an intensive quantity because it doesn't depend on amount. As long as the cubes are composed of the same material, their density will be the same. All right. So suppose we have a 25 cc sample of gold, and it's found to have a mass of 482 grams. We can determine its density. Density is mass over volume, and that's going to be 482 grams divided by 25.0 cubic centimeters, and that's going to be equal to 19.3 grams per cubic centimeter. all gold has the same density, 19.3 grams per cubic centimeter. By comparison, water's density is 1 gram per cubic centimeter. Gold is a very dense material, and one of the ways they were able to tell when people prospect for gold, whether they were bringing samples that were true gold or were something else, like iron pyrite, which looks very much like gold, is to measure the density, because iron pyrite has a much lower density than gold. Okay, well, now we can ask ourselves, what's the mass of 2 cubic decimeters of gold? A cubic decimeter is a liter, or about a quart. In order to do this problem, we remember that the density of gold stays the same regardless of how much we have. So what we have is a volume of 2.0 cubic decimeters. Now, we can't use our intensive property to convert that into a mass as we're supposed to, because the units don't match up. We have cc's there, we have cubic decameters here. Well, it turns out there are 10 centimeters in a decimeter. And in order to get that into a cubic unit, we're going to need to cube the term. And that means that we've got 2.0 times 10 to the third cubic centimeters. Well, with 2.0 times 10 to the third cubic centimeters, and a density of 19.3 grams per cubic centimeter, it follows that we've got 3.86 times 10 to the fourth grams, or 38.6 kilograms. So 2 liters of gold weighs about 38 kilograms at 2.2 pounds per kilogram. That's about 100 pounds. Last, what's the volume of 2 milligrams of gold? So now we're asked for a volume given a mass. Again, density relates volume and mass for a pure substance or a homogeneous mixture. The density is always the same. So this time we'll start out with our 2 milligrams of gold. Notice we start every one of these word problems with the information we're given. And again, we have a units problem because the density is given in grams, not milligrams. Well, it turns out that there's 1,000 milligrams per gram, and so the way I can change this is 1 gram over 1,000 milligrams. That means milligrams will cancel, and now I know how many grams I've got. To figure out the volume, I'm going to need to use the density in such a way that I can get an answer in cc's and eliminate the unit grams. So it's true that 19.3 grams is equivalent to 1 cc for gold, and it's also true that 1 cc for gold is equivalent to 19.3 grams. In other words, to say that you have 19.3 grams and to say that you have 1 cc is to say the same thing. So I can in fact multiply this by either 19.3 grams per cc or 1 cc over 19.3 grams. But if I do that, my unit grams will cancel and I'll get my answer in cubic centimeters. 1.04 times 10 to the minus 4 cubic centimeters is the volume of 2 milligrams of gold.